quick introduction, this is Simangaliso, and he was at our beginner's day, was bold enough to ask for a conference ticket, joined us, and is now doing a lightning talk. So, over to you. Oh.
Hopefully the timer didn't start. Hello guys, my name is Mangaliso Senpako from my Think Correct. Essentially my talk is going to be about a struggle I had not so long ago. I was working on a full stack project. It's picking up a bit. There you go. That's better. All right. Okay, so I was working on a full stack project with a front-end developer, and the problem was that he was asking for way too many endpoints. And by the way, my topic for this talk is one GraphQL endpoint, 5 minutes of your time. So essentially with GraphQL, what you can do is you can create one endpoint, and then if the front-end developer or anyone in the front-end requests for something different, you just give them a query for that. So essentially what I did is I built in GraphQL and Django in the backend, and then this is what I gave to him. This is actually deployed on render, so he could visit it even when I make updates to it. So with GraphQL, what you can do is you can specify exactly what you are looking for, so you don't have to query for more than what you need. Also what I did is I applied pagination to make sure that I only get the products that I'm looking for. So this was an API for an e-commerce website. It was just the final project at school. But what I wanted to introduce people to, if you've been fighting a front-end dev and you feel like he has been asking for way too many API endpoints, GraphQL is the way. You can build very cool resolvers for that. Resolvers are practically the way you can actually handle how data is accessed, and this also increases in a sense that you can actually protect the data that you don't want people to actually get access to. So if it's authenticated data like someone's card, you can actually request a Pera token for that. Yeah, any questions? Okay. Thank you.
Makes my job very easy. That was 2 minutes.
Yeah, you win. And next up we have Angelique from the Software Carpentries. And I'm sorry, we're not going to do questions just because it won't, but find him afterwards and ask him a question.
Take at least 3 minutes of his time.
Thank you.
You see my crypt notes? Oh no, okay.
It looks like the proper slide, building Python community. Yeah.
Don't worry, there we go. Right, hello everyone, my name is Angelique Trussler and I'm the Associate Director of Community at the Carpentries. We're a global not-for-profit that teaches data science and programming to scholars like you in the room. Quick question, how many of you in the past have had to explain a coding programming term in your mother tongue? Just put a hand up for me, I have. So in isiZulu, Swahili, Kiswahili, have you? Was it easy? No? Will you do it again? No. Okay. And this is where Glossario comes in, right? Glossario is a multilingual glossary for computing and data science terms. And what we do here is it's a community-led project. We take more than 600 English terms and we are translating it into 26 different languages. It's not limited, but this is the 222 volunteers that have contributed thus far. This is the languages they wish to translate into. 7 of those are African languages, right? So I would like to tell you today how you can contribute to Glossario. So if you go to our webpage, you can see the various guides that will help you to contribute. But I want to take you through the 3 main ways you can help us. You can choose a language you would like to contribute in. I chose Kiswahili because I thought it's very appropriate for the audience here today, right? You can click on the show terms that need translation. It will extend with all the terms that we still need translations for. Now, I am deciding I want to translate the +1, and that's a very carpentries thing. When you vote for something, or you approve, or you say, +1, yes, I like your idea. So you have 3 different ways you can contribute to this glossary. You can use a Google form. Some of the information will be populated, for instance, the term that you want to translate, as well as the language you are going to translate it in. Basically 2 things we need from you: the translation and your GitHub account, because we want to acknowledge your contribution. Next up, you can submit a pull request in GitHub. There's a detailed instruction manual on our website. You can download that and work through it to make the pull request. The next one is email us. Also include your GitHub account, because we would like to acknowledge your contribution. Next up, you're going to see this is what the contributions look like. It's a bit tiny on your end, I think. 222 and counting. We put you on a page. We want to celebrate you. Next up, contact me if you have any questions. If you would like to see what Glossary is all about, scan this QR code. It will take you to my digital card. What do we call it these days? Like, let's say my business card, right? It'll take you to the Carpentries website. It'll take you to Glossario, and also we can schedule time to chat to me about the Glossario things we do at the Carpentries. Thank you very much. That's it.
It's so weirdly sad that I can only contribute in English, which is useless. So, but the rest of you, I'm sure, have more languages, so that sounds really amazing. Next up, we have Vuelwetu, who's talking about building a Grafana app. Over to you.
Thank you very much. Afternoon, everyone. Okay, if you can see that. Okay, my name is Vuelwetu Mfidi. I work for Nikis as a software developer. So my talk today is about building a Grafana app with Streamlit. So just to give a background and an introduction why I came into that. So basically the dashboard is built in Python. Entirely everything is Python. Used an open source library that lets you turn simple Python scripts into web applications. So basically, this is a no HTML, no CSS, no JS that has been used, which is the front-end technologies. Basically, Streamlit as an open source library. You can build web apps. You can do data visualization, prototyping, as well as sharing insights as well. So the goal for this, basically, I work in an environment whereby we provide services in HPC, which is high performance computing, and cloud as well. So one goal to this is building a Grafana style dashboard that can display your system and server metrics as well. The focus was on creating a clean, interactive interface where I can explore trends and control what I can display using filters and sliders. So basically what I mean is, with this library, I can customize my own dashboard, my own metrics, my own logs as well, server logs. So key metrics here, CPU usage, RAM, and disk usage as well. Your Nginx requests, error rates, as well as real-time logs. So basically, this is what it looks like. If you can see on the side there, I've got all the filters. You can also view your metrics based on your intervals if you want. So this is all these components that you can see on the screen are basically Python, and also the charts that you can see. You can integrate Streamlit with any Python library if you want, your pandas, your plotlists, and all the other libraries and packages as well. So basically that's that, and the logs as well. You can see the system logs, Nginx logs as well. This is very useful as well in terms of monitoring your system and your server as well, just to see your error logs and all the other metrics just before it gets to the users as well. So yeah, basically that's that. You can contact, share ideas, and collaborate. That's my name, Vuelwetu Mfidi, my email address. I'm always available on LinkedIn and my GitHub as well. So conclusion to this, basically, building with Grafana with Streamlit timing empowers developers to build visually appealing, data-driven apps in just few lines of Python. So basically, the project reflects the spirit of using Python to create tools that are simple, powerful, and open as well. So one of the other things as well, just to put it out there, this is not replacing Grafana. Grafana is the standard tool that is being used to monitor our systems. So this is something that I decided to build and customize my own metrics as well. So yeah, that's about it. Thank you.
I'll note I've also just learned how to pronounce the name of your employer. I was saying Nisus. Nikus. Nikus it is. Okay.
Thanks.
Thank you. And given that we're not doing questions, find people afterwards to ask them about their projects. Next up, we have Liam, who is going to talk to us about being an astronomer, or a developer from an astronomer, I'm not sure.
Thank you. So my name is Lemuel Harang. I'm here to talk to you and trying to motivate you to reach for the stars. And I'm going to do it by providing a practical guide for a career in the space industry. So when I was young, I had a dream. I kind of wanted to build a Dyson sphere. But yeah, people said, no, only NASA does this. First you need to make money. You're not smart enough. Childish dreams, grow up. So how many of you have crushed dreams like that? Maybe it's not just a crushed dream, it's actually a spacecraft not launched. So fast forward today, I'm a bit of a hard-headed person. I went on, I work for the Meerkat on a radio astronomy, and some of my past experiences have actually been testing spacecraft components. But a lot of my friends didn't make it. They did some boring jobs that made the money, and even trying was not an option anymore. So I'm here to motivate you. If you have the funding, just go to university. I'm going to help the other people. Some interesting things can be material science, mechanical engineering. There's a lot of moving components. Physics, you'll see all the telescopes, antennas are white for thermodynamic reasons. Electrical programming, we use a lot of Python, hint, hint. Moving on, so I'm going to do a few simple examples. Let's say you had to get a job and you chose generic HVAC, air conditioning. So you do that for 4 years, but you have this dream for space, but you don't have the funding. So you can realize that sometimes dust is a problem, or moisture control. So you can move up into spacecraft cleanroom HVAC, and then you can do that for a while until you get bored and you want more money. So then you can exit the space industry and go to the medical industry or semiconductor chip manufacturing. That's one example. Another guy, he works for Rocket Lab now. Another one is software dev. Python, obviously, but you don't have to. You start out as a Hello World dev, think you know everything. Then you decide if you're back-end or front-end. And from there, we can move on to advanced GUIs. We've got some people here. What you see there is a visualization of all the components on one antenna. And DevOps, ML, high-performance compute, you have heard all of this. I'm not going to go into that. If you start out as an assembler, maybe you just did electronics PCB assembling, or a solder technician for maybe Denel or Hensoldt or whatever. You can upgrade that by getting a small course. You can become a spacecraft PCI assembler. You just have to carpet bomb them with about 1,000 CVs, but it's doable. Then you can become a test technician, upgrade that to an ADCS test designer. So you design it for the company, integrate that into a database. And then if you get more money, yeah, you've got enough experience. Everyone's going to hire you. Last one, if you like games and you get sidetracked a lot, you know, I think there's a lot of people there. You start out as a generic gamer, maybe shooting games or whatever. Then you find these weird things called Factorio, and your life goes away. Some people do Kerbal Space Program, which is basically launching your own rockets, but without the consequences. I know a few people that took that and built some simulations in Pygame, and then with that, they got a job. And then from there on, you can just go system engineering, GIS tech, machine learning. It's open. I hope I could show you some stuff. So if you have a dream, go for it. Doesn't matter if people put you off. You design your future. So from the Meerkat team, I just want to say, Hakuna Matata.
Next up, we have, I think, David, who is the last person, unless there are any other people who put ones in after I last checked the form. Anyone else? Okay, in that case, it's you, David. David is speaking about Meteor at the Rock Parade, which sounds like a song title.
It does. So hopefully we'll get this screen up. And no, it's decided to show something very different. That's not even my screen. No? Yeah, no. Okay, come here. You little friend. Everything's glitching. Here we go. Look at me trying to make my entry for the Velkey thing. By the way, submit the Velkey thing and get the thing. Okay, my talk can start now, I suppose. Sorry about that. So Meteor at the Rock Parade was a song. It's a song that my daughter and I like. It's actually Meteor at the Love Parade. But we had to come up with a name for our team at the NASA International Space Apps Challenge. So it was the first time I actually did a father-daughter team at a hackathon. It was really amazing. Strongly recommend if you have young people in your life, take time to hack with them. So the NASA International Space Apps Challenge completed. All those dots on the map took part. That's not really interesting. These are the challenges. They're still, the data for them is still open, and the challenges exist to get us to use open data. There are these 19 challenges. They vary in difficulty. There's all sorts of stuff you can do. But since I have a good friend who's a hypervelocity impact crater specialist, and my daughter is really interested in Planet Y, we chose Meteor Madness. And Meteor Madness is this challenge because there's this newly identified asteroid, Impactor 2025. Now we want to actually explain to people what it would mean if something like that would kashmushi into the Earth, and what would the consequences be. So this challenge was to develop an interactive visualization and simulation to take the data on the near-Earth objects and do something with it, right? And that was kind of as broad as it was. And so then... Hey, no. I killed that somehow. Okay, is it here? Yeah, there we go. So this was our team, Meteor at the Rock Parade. The cool part is, under members, you see the two of us, yay! My daughter is suitably anonymous, at least with her picture. And in our project, what we did was we used the NEO data to fetch asteroids near Earth, and then showed you where they would be, and then you could click on one, and then you would see data about it. But since this is a demo and a lightning talk, and I don't have much time, this is the project. So this is Rock Parade, and here you can see our solar system. Those circles are lunar distances around the Earth, and as we play, you'll see all these little yellow dots and red dots zooming past. That's like the asteroids whizzing past us all the time. Luckily, they tend not to hit us, but there's a lot more than you would think, and this is in the next 6 weeks. Right, from when we had the hackathon. And so you can scroll down, September 27, 28, 29. Let's see what will probably happen tomorrow, October the 9th. If this one, is this, that's a teeny weeny one. I want a bigger one. 2021 ED5, potentially hazardous. Are you gonna work? Yeah, okay. So now, if 2021 ED5 was to hit the Earth, we got all its orbital data out, it would have 2,900 megatons, which is about 195 times the Hiroshima bomb. It would make a crater 2.5 diameters, and those are all numbers, which suck, so we made a map. And here you can see the meteor coming, and all movies focus on the damn United States of America. So this map is on South Africa, and what would happen if the meteor were to hit in South Africa. And for this talk, I introduced my daughter to Claude for this project. So we were using Claude Code to help us think about stuff. So we didn't actually pick Pretoria. I don't have anything against Praetorians, but you see these circles evolving, right? So the first one was the fireball, where everything is vaporized, then total destruction, then the severe blast, and then the thermal radiation and the air blast. And within that thermal radiation zone, people are getting third-degree burns. Within the blast effect and total destruction zone, there's severe damage, and there's probably potentially millions of casualties within 270 kilometers. Now, my daughter likes books, and the books that you read when you're 12 years old are quite dark sometimes. Like the books she reads, she likes authors who are quite severe. So she said, can we prompt up the AI to generate some stories for us of teenagers inside the blast radius writing their last journal entry? And in the style of her favorite author who wrote, my brain's not, she just won't forget me forgetting, and so here's a lady aged 18, 5Ks from the impact site somewhere near here. They're playing jazz at the corner cafe. Someone thought we should have music. So Bro Moses pulled out some old cell phone and started playing, and now there's a whole impromptu concert happening. It's the most Pretoria thing I've ever seen. We're taking turns pointing out constellations, making up new ones. That's the Jacaranda. That one's the Bryfork. That one's Mrs. Malherbe's disappointing stare. Someone's got a Bluetooth speaker playing Shosholoza. Everyone's singing along. Even the white kids who don't know all the words are trying. It's beautiful and absurd and so perfectly South African it makes my chest. I can see 2001-85, a bright point moving across the stars, getting closer. We're still...
Done. David, you can buy me that beer later for that cliffhanger you asked for. Yeah.
We actually have one last minute submission. Yeah, that was amazing. We have one last submission from, you see there, on Django endpoints. While you set up, I'm just going to tell you guys, my mom was worked for a newspaper in the 80s, and they got an alert that some kind of asteroid was going to hit South Africa, and they weren't allowed to tell anyone. So for like half a day, she thought society was going to crumble, and she couldn't tell anyone. How crazy. Anyway.
Good afternoon. From one of the ICT, sorry.
Yeah. Just pull the microphone slightly further away from you. There we go. Yeah. No, not quite that far. Yeah, there we go. Perfect. Yeah.
Okay. I'll be talking on building Django Ninja endpoints lazily. This friend of mine, he just created this Django library called Lazy Ninja. You can please scan the QR code if you have any question, but basically you were still scanning? Okay. If anyone was still scanning.
I suggest you put it up when you're done.
But
people
basically, it generates endpoints using Django Ninja. Just your Django models. You just create Django models in Python classes, and then it dynamically creates endpoints for your Django application. And besides that, it also creates all of the endpoints like forget, get one, get list, delete, update, and everything. And it also gives you a documentation for your endpoint. So if you are lazy, like me, you just don't need to be writing all of those code, adding the words there, the codes, and the rules, whatnot. You just use Lazy Ninja, and then you have your endpoints using Django Ninja easily, just creating your, how do you call that? Just creating your Django objects, and then voila. And something else that it brings that you can actually generate identity model if you want to add the validation for your models, for example. And you can also generate open API clients for different languages. You can generate for JavaScript. You can generate for Dart, Python, Java. You can just write a command line, and then you have the clients there using OpenAPI. You just copy and then you add on your front-end application, or if you are using the endpoint on Java or Dart, you just add there, and then voila, you are using the endpoints on your mobile application, your web application, and everything is there. So if anyone was still scanning, you can go and scan, and basically this is what I wanted to share with you guys. Django Ninja, something that will help you to create Django Ninja application lazily. Thank you.
Let me know when my time starts.
Has just started.
Cool. Okay, I've added some extra excitement for myself. My battery's about to die, so either I'm going to run out of time or my battery's going to die, one of these two things. So something that's come up a couple of times, and I think is really cool, is that we all know about LLMs, there's lots of them out there. But something that people don't realize is that there's actually a very active scene, and it's a major area of open source development around running LLMs locally on your own hardware. And this is great because it means that your data is not then going to some dodgy foreign multinational. And for all sorts of reasons, that's a good idea. And it's also quite a lot of fun because often you get to mess around with cool hardware stuff. So I'm just going to take you on a lightning quick tour of our setup. So you get something cool like this, which you can see is like a front end that looks remarkably like ChatGPT. And I'm going to press go, and then I'm going to talk through other stuff and hope that it finishes while we're talking. The starting point is, and I really recommend, there's two projects, but I like this one called llama.cpp. It started out as an implementation of the Meta Llama model in C++. It's since grown legs. It's spawned a whole model standard. So pretty much if you want to run a model, you can use llama.cpp. There's a couple of ways you can interact with it, but probably the best way to work with it is you can run a server that exposes something that looks a lot like the OpenAI endpoint. So it's just like using OpenAI, but instead of you just swap out the URL for your local URL and you're off to the races. Then the next bit, and Henri mentioned, there's even Python bindings for llama.cpp. So if you don't want to mess around with all of that low-level stuff, there's a higher level friendly interface for it. I must note that these seem to be getting a little bit stale though, and I think that's more an indication that llama.cpp has gotten easier to work with, so people have felt the need to use high level bindings less and less. So up until recently were using those, but have now switched to a different setup. And the next bit is this bit. Let me zoom in a bit. Okay. This is actually as complicated as is. This is the config file that drives our llama.cpp. You tell it we're using something called llama swap, which I'm not going to go into now, but it's basically a way to easily swap between different models. And then this is the command that it's actually running using llama server. And you're passing in a parameter, which is this guy. You're passing in the model file, which is this guy. It's somewhere between 5 to 10 gigabytes big normally, and then there's a few other parameters you pass in, and you can go on an exciting journey to learn exactly what are the right parameters to pass in for your particular model and your particular hardware, whether it's CPU or GPU. We're running everything on GPUs. And the other thing that's important is this project over here, which is OpenWebUI, which is a very fancy website. And this is the thing that gives us that cool front end that looks a lot like the ChatGPT interface and does user management and stores conversations for posterity, and now has all sorts of cool extensions. And this is what the configuration for that looks like. A little bit less friendly because it's Kubernetes. But basically, we're actually customizing very little, mostly just pinning versions and things like that, setting some endpoint names for this internally, and off we go. And don't worry, I'm not leaking any secrets here. So back to our original one. Let's see if it's actually done anything. Haha. So this is something that we've done, and having an internal endpoint for something like this does allow you to then have an internal, to start experimenting with things like tools. So we have a particular API. I built a tool that allows you to interact with that API. I see that it's taking quite a long time to respond. I worry that the infrastructure has gotten unhealthy, so I'm just going to load a previous conversation to illustrate this. But what you can do here is you can see I'm calling the API, I'm telling the model, it's calling the API, and it's getting responses, and then it's doing cool stuff with those responses, like drawing maps and doing other interesting things. So, thanks for listening.